All right, is there anybody watching that can hear me? All right, is there anybody watching that can hear me? Maybe throw something in the YouTube chat or All right, is there anybody watching that can hear me? On the Discord. Awesome. Is there anyone here who's a student, not a mentor? Anyone here who's a student? Go ahead and say something in the chat. Don't be shy. Go ahead and for those of you who are here, I think we're going to start in about 2 or 3 minutes, just to see if anybody was a little late coming on for 6 o'clock. In the meantime, make sure you guys have processing up and running. And hop on the Discord server. I'll be talking about that once the lecture starts. Anyone who's watching, feel free to shout out to me in the chat just to see if it's working. If there's any students out there, let me know you're here. Greatly appreciate it. I think we'll be starting in about 2 minutes. Less than 2 minutes. Alright, looks like we've got about 16 people watching. Should be good enough to start. Again, if you're just joining us and you're a student, throw something in the chat so I don't feel like I'm talking to thin air here. So first things first, this is obviously the first lecture we've had back since our last Monday lecture 2 weeks ago. Since then, we've obviously created a YouTube channel. Hi Tristan, how are you? Since then, we've obviously created a YouTube channel. Our lecturer from Saturday had a live stream at his regular time on Saturday. Seemed to go pretty well. We've also posted a couple of videos. We have an update video just explaining the whole situation and what we promised to deliver for all of you guys. I also uploaded a video a couple days ago that went over the Pong example and if statements from the last lecture we had. I know a lot of students were interested in the Pong game because that's sort of the first experience we've had actually coding a real game. So if you'd like to review that, go over to the YouTube channel and watch that video, and I walk you through exactly how to get that going. For now, we're going to get started on this lecture. Before we start, I just want to throw it out in the chat if you have. Has anybody signed up on the Discord server? And is there anybody that knows how to work it? Can anybody throw a chat in general on the Discord server? This is where all of our mentors are, and they're all ready to help you out if you guys have any questions. So throw something in the Discord server if you guys are joined on there. Until then, let's go ahead and get started with this lecture. So this is an overview of what we're going to be doing today. Turkey Slurp said yes. Good name, Turkey Slurp. So this is our session overview. We're going to do a quick review of if statements, else if, and else statements. They're all very similar, kind of related to the same thing. We'll go over what all those are. We've got logical expressions, and then we're going to be talking about some new topics, lists and loops. So we'll dive right into the review. So I know it's been 2 weeks since we did this, but we have if, else if, and else statements. So you remember the whole idea with if statements is that sometimes we want to run a piece of code, sometimes we want to run a different piece of code, sometimes we don't want to run any code. So we can customize different if statements to run different pieces of code at different times. So in this example here, we're going to draw a circle every single time, but depending on the situation, we're going to fill it with a different color. And then we have it reflected over here. So if mouse Y is less than 500, we have it as a red circle. Down here it's a green circle, and here it's a blue circle. And we describe that using the mouse Y variable and checking to see what its value is. If it's less than 500, which means it's in the top half. If mouse X is less than 500, which means it's in the bottom quarter on the left side. And then in all other situations, that must mean the only other possibility is this bottom right-hand corner here. Okay. And we do that, we fill the if statements with logical expressions. And you can have logical expressions that are made up of multiple checks. So for example, in this statement, the top one, programming is fun and useful. So we could have a logical expression that's just programming is fun, and then another one after it that is programming is useful. But if we use the keyword and, we can combine them together. And this would be true because both of them are true. The opposite is this one here, which is an or. So you can combine logical expressions using either and or. So and only evaluates to true if both things on either side are true. Okay? With or, only one side has to be true. One or the other side has to be true. So in this example, water cannot be liquid and solid. Either one or the other is going to be true. So if you put an and here, the whole thing is going to evaluate to false. But in this one, if you put an or here, only one side has to be true. So at 22 degrees Celsius, water would probably be liquid. So this side would be true, and because it's an or, the whole thing gets evaluated to true. I have a question in the YouTube chat that says, "Hi, how can we go to the coding site?" So I assume you mean the processing website. I'll do a quick demo of that. So you want to open up a browser. I'll show you Schulich Ignite's website and the processing website because I'm not sure which one you were referring to. So the Schulich Ignite is just at schulichignite.com. This is our website. You can see all the slides and everything are here. This is our lecture today, Listen Loops. The other website is processing.pi.org. Nope, that's not it. Go to processing.org, and then in the top left, click processing.pi. Oh, it's pi.processing.org. And then here you can go to reference, and then this has all of the functions that they let you call. So for example, here's a description of what draw is. Draw and setup. Your shapes are also going to be here. So you can see rectangle, square, circle, ellipse. All of those are going to be here as well. Okay. We'll head back to our slides here. So here's a more complicated example using logical expressions. So instead of our example back here, where inside of our if statements we actually just check the variables and their numbers right there, we can actually pull it out to the top here. Now all of these are going to be Booleans. If you remember, we have different variable types. We have integers, decimals, strings, which are words, and Booleans. So these will evaluate the statement over here and check if it's true or false, and then stick true or false inside this variable. And this lets us sort of put in one extra layer of organization. So we can say if the mouse y coordinate is less than 500, we know that'll be in the top of the screen. And we can do the same thing for the bottom, the right, and the left side. So now we have a variable to see if it's in the top, bottom, right, or left. And then we can combine them in any way we want to get these really organized statements. So then we can just say if it's in the top and it's in the left, then we can fill it one color. If it's in the bottom and the right, we can fill it another color. Else, we can fill it a default color. So this is really easy to see what's going on. This obviously runs if the mouse is in the top and the left. But like we said in our last slide, because we're not using or, we're using and, both of these have to be true for this fill statement to run. Okay. And down here we have another similar thing. We can get a square to be drawn if it's on the right side but not the bottom, which is to say the right side and the top. Otherwise we get a circle to be drawn, and we can see here it's a square only in the top right. Okay, and we also went over the mouse pressed variable. We didn't really go over any cool examples that we can do with that, but obviously all of the games that you want to code, most of them are going to be using mouse clicking stuff, so this is a good variable to practice using for coding games later on. And we're going to have lots of examples that require you to use the mouse pressed. So really quickly, we're going to go over fairly quickly these bouncing ball examples. So these two are very similar. This one just has it moving up and down as well as left and right. As I said at the beginning of the lecture, I did a video a couple days ago explaining exactly how to code both of these, and then we took it one step further and we actually coded the full Pong game that we left off on our last lecture. So we're not going to take a break to do these exercises right now, but if you have time after the lecture, go ahead and check out our YouTube channel and you'll find that video explaining how to go through these exercises. So we're going to jump straight into our content, lists. So what's a list? So a list can hold multiple values, handy for storing a lot of whatever you want. So for example, before we only had the ability to store one variable at a time. So we could store a variable called student, and then we would only be able to assign one of these names to student. But now we can have a variable called students, and we can hold as many names in there as we want. So for example, all of these names and more, you could hold all the students' names of your class. Obviously, they all have to be the same type, so they're all going to be names of students. You wouldn't have one as a name of a student and another one as a number and another as an address and another as, a true or false Boolean. They all want to be similar variables. And obviously the main advantage is that it lets us reduce the number of separate variables we have to make. So if we have 20 students, we can make one list called students instead of making 20 variables called student 1, student 2, student 3, student 4. So how do we make lists? So these little square brackets, that's what these are called. So really quickly, I'll jump into processing and just illustrate some differences between these. First of all, let me make my font a little bigger. Perfect. So we have a few different types of brackets. These are regular brackets, these are square brackets, and these are curly brackets. Okay, and they're all called brackets. Okay, so when you hear me just say brackets, I'm talking about these. Square brackets are these, and curly brackets are these. We're actually going to be using all of them today. Okay, so the square brackets tells the computer that we want to make a list. Lists can hold any type of data, numbers, strings, booleans, or anything else, but you want to make sure that you're using the same variables in one list. So you need one list for random numbers, and you need a separate list for students. You would never have 4 random numbers here, and then put another comma here and add these 4 names afterwards. You always want to separate your lists, mainly for organization, partially because the program will start to do some weird things that don't make sense if you start to combine variables. Okay, so inside a list. So here's the weird thing, is that if we have a list here, you notice we initialize it very similar to how we initialize a variable. We just put a square bracket in on either side, and then put all of our values inside, separated by a comma. Now the weird thing about lists is that they start at index 0, and you'll see what I mean by that. This is how a list is stored over here, and index 0 is 101, which was the first variable we put in there. Index 1 is -2, which is the second one. So it kind of doesn't make sense now, but it'll make a lot more sense later on. We have another question here. How do you get to the coding page? So are you talking about the website, or are you talking about this area here where I've been throwing some code up? Which one are you talking about? Yeah, that area. Okay. So that's the area that we've been coding on. It's called processing. It's the program that we use to code everything. So just give me 1 second here. All right. So processing is this little app right here. We have instructions on how to download it on our YouTube page. Once you open it, it looks like this. Like I said, it's kind of an app just like your browser or Discord is. We have instructions on our YouTube page for how to download it. We also have instructions. There was an email that was sent out to all the mentors giving you instructions on how to download Discord and download processing, this app here. Just really quickly, you can go to processing.org. And there's going to be instructions for how to download it here. So hopefully you can get that sorted out quickly and come back and join us. Hopefully I answered your question. So let's continue with lists here. So we ended off, that's the video at the time of the processing installation. Right. I'm not sure what you mean by that. It seems like I answered the question well enough, so we'll continue with this. So I said that lists all start at 0. You can sort of think about this 0, 1, 2, 3 as how many items you want to skip over to get to the one you want. So the first one, you skip over 0 items to get to 101. To get to -2, you have to skip over one item. You're skipping over this one. So to get 303, we would skip over 2 to get to 303. So I'll do an example of that really quick in processing here. Now we want to just create a setup really quick. So we don't need to worry about our size or anything for that display window, because we're just going to be dealing with a print statement here. So to create a list, like we said, we'll create a list called numbers. And instead of making a single number like this, we want to create a bunch of numbers. And we do that by having a square bracket, and then we just start putting in any random numbers we want. Negative numbers if you want. And let's try and print one out. So we're going to go print. Now we want to go numbers, and then we want to print out, let's try 121. So to get to 121, we have to skip over 1, 2, 3 numbers to get to 121. So this is going to be numbers at index 3. And if we run this, we get 121 printout down here. Perfect. Let's say we want to get 23. So 23 is the weird one because it's the first number, but it's actually at index 0. So we print out numbers at 0, and we get 23. So that's how it works. If you try and print out, this one would be 1, 2, 3, 4. Skip over 4 to get to -1. If we tried to print out 5, it wouldn't work. We'd get an error. We'd get some weird behavior happening that doesn't make any sense. So be careful that you're only accessing however many variables you have in here. So it wouldn't make sense to put in a really big number like 234. That would only make sense if you had 234 numbers in here and you wanted to get the last one. Okay. So we'll continue with our slides here. So now what if we created a list like we have here, but after we already initialized it, we wanted to add more numbers in here. We could just go in here and add another number if we wanted to add 20, or we could use what's called append, and that's numbers.append. So for example, we can make an empty list, and then we could add in all of these elements afterwards. And that would essentially create the same list as if we created one with all 4 of these already in at the beginning. So if we go back here, let's try and recreate this array or list, but start with an empty one. So we could go numbers equals an empty array. Okay, now we have to put this so that it knows that it's a list. Sorry, I keep saying array. It's a list. So that we know that it's a list. If you say 0, it thinks that it's a regular number, not a list. So we put in these square brackets. And then, just like in the slides here, we go the name of the list dot append. So if we go back here, we can go numbers. Let's try and recreate this list dot append 23. And then we'll go numbers.append 53. Now let's see if this works. Let's try and print out. We'll print out the first, element number 1, which is this one. Skip over 1 to get to 53. We'll do the same print statement here, and hopefully we get 53 printed out twice. Once for this one, and once for this one. 53, 53, perfect. Now if we wanted to create the rest of it, we would just copy this, paste it a few times, and then we could change this one to 863, this one to 121, this one to -1. And now at this point right here, we essentially have two versions of the word numbers. Now I should actually call this one something different. I'll call this one numbers 1, and then this one numbers. So now here we have two lists, numbers 1 and numbers, that are essentially the same list. They have the same things in them, except we built them in different ways. Okay, now you might be asking, why do we even need this append thing? Well, it's actually pretty useful if you want to add something onto the end of a list that you didn't create, for example. Sometimes processing will give you little lists for your keyboard or for something like that. Okay, let's head back to our slides here. So what if we need to know how long our list is? We can use this thing called length. LEN stands for length, len. So if we have a list here called students, and we put those 4 names that we had in, if we want to print out its length, we could put length of students, slap that into some variable called amount, and then print out the amount. And this will print out 4 because there's 4 in there. So if we try this, we'll get rid of this top one here. If we have a list called numbers, and we add in 1, 2, 3, 4, 5, we could have length of numbers, and we'll get len of our list numbers. Okay, now remember, this one is one of those functions that processing gives us. It uses round brackets, not square brackets. And then here, if we want to print out how long it is, print out length of numbers. And we should get 5 printed out. Perfect, 5. Now again, this is useful even though we can obviously see here how many times we've added this in. There are lots of scenarios where you've got a list that you didn't create, or you've made so many appends to it that you can't keep track of how many times you've done that. And we'll get into more of how that can be useful later. So using lists is just like using variables. So what we mean by that is, I'll get rid of this for now. I'll get rid of this, I mean. So if we have a variable called x, and we make it equal to 10, okay, now in here, we can print x, and then after it, we can print numbers at 1. 1 would get us 53. We skip over 23. Now, x and numbers at 1, we can put them in print because they effectively behave the same way. Okay? If we put numbers in, this wouldn't really make sense. Here we obviously want to print 10, But here you put a whole list of numbers. Which number did you want to print? But once you specify a number within that list, now this behaves exactly like a variable. If we want to, we could go numbers at 1 equals -5. And we can assign it a new value just like we would assign x a new value, -3. These are the same thing. But if we try to do numbers without specifying which element we want to change equals -5, this doesn't make any sense, right? I'll put a little note here. This doesn't make sense. Okay, because numbers is a list. Which element were you trying to change? Were you trying to change, usually when kids do this, they mean, I wanted to change the first one. But you have to put numbers at 0. Okay? So, saying numbers equals -5 doesn't make any sense. But once you specify an element, now it behaves exactly like a variable. So just like any other variables, you could throw a list with a specified element inside a value for a circle. So instead of printing it at x, y, and size, you could have lists with specified areas, with specified elements in each 3 of these values. So they behave just like variables. Or you can use them to calculate other variables, just like this. Or you could say sizes at 1, have that here equals x plus 3. You could change the order. You could have these on either side. Once you've specified which elements you want to get from the list, you can treat it just like a variable. That's the whole point we're trying to get here. So we have an exercise 1. So we're going to take a break and do an exercise. Also, if anybody's having trouble installing, processing, getting that coding window up, we can help you out right now as well. So the exercise is to use a list to draw 4 balls that will move down the screen at different speeds. We have a little hint here. Use 2 different lists, one for their speeds and one for their y positions. So if you remember, the way we did this last time was in our def setup here. To get one ball to move down the screen, you would have to go y equals, and we'll start it at the top of the screen. Then we have a speed, which equals, say, 5. Now what you would do is in your setup, you would create a size, say 1000 by 600. And then you would create a draw, and you would go, first you would draw a background, and we'll just make it black. And then you would draw a circle. And that circle would be at x value, we'll make it right in the middle, 500. Y value, we're going to make it this y value so that we can change it. And we're going to have a random, whatever diameter you want, say 100. And we have to get access to that variable y, so global y. And we're going to be using speed as well. Now, how do we get y to move down the screen? Every time we go into draw, add the speed to y. And if we play that, we should see the ball moving down the screen. So we've already done this. This was lecture 2, I believe, and we added on to it in lecture 3. But right now, the whole exercise is to try and get this to work with 4 circles moving down the screen, or 10. And obviously it would be easy to do that. You would have to copy this, paste it, and maybe you would make this, you'd make this one 1, and you would make this one 2. and then you would have to draw another circle at y2, and you would have to import another, right? You would have to import a whole bunch of them, and then y2 and speed 2, and then y1, and then you would have another circle that's y2, and then you'd increment y2 by that speed. But to do that 5 times would take so long, which is why lists are so helpful, because you can have, as the hint says, you would have one list for their speeds and one list for their y positions. So we can have one list called y positions, or you could say y position, and just remember that it's plural. And then you can have a whole bunch of y positions in here. Okay, and then you would have a second one called speeds. And speeds, you would have all of their speeds in here, and you would initialize them in there. Okay, and this is a good way to keep track of all of your variables. We're going to give you 5 minutes, 5 or 10 minutes to go through this exercise. Please, if you have any help at all, send me a message in the YouTube chat or on general on Discord, and I'll make sure we get somebody to help you out. Okay, so go ahead, and if anybody doesn't have processing installed, if you don't have this window installed, throw a message in YouTube or on the Discord, and I or somebody else will give you a hand with that. All right, everyone, we're about halfway through the exercise. We've had a couple students asking for help on Discord, which is
All right,
great.
everyone. We're
Anyone
about halfway through
who
the
needs
exercise.
help, feel free to send something on there. If anybody's finished the exercise, feel free to just throw up your code on general, and I can take a look at it, or one of the mentors can take a look at it, and send a screenshot if you think you finished it, show off to all the other students. Just feel free to share anything you have on Discord about the exercise. Um, if you want like a little extra challenge, if you finished early, that one of the mentors can give you, anything you want. All right, everyone. Try and wrap up what you're doing. We're going to go ahead in about 30 seconds, and I'm going to go over the answer to how to do this. I've been coding it for you in secret. And we can talk about how this works, and then we're going to talk in the next 10 minutes about how to simplify this to make it even more organized and really nice. Okay, so as you guys have seen my solution here, we have these lists at the top, Y position and speeds. So this is the Y position of each of my balls, and then this is the speeds for each of those balls. So this speed corresponds to this position because they're both number 0. This speed corresponds to this one to this one. In fact, I could add some spaces in here to make it really obvious how these line up. Okay, now as you guys saw, how many do I have here? I have 4. So I have 4 circles, and each of the circles is going to be drawn at each of the y. So I have one circle for 0, 1, 2, and 3. Okay? Now these are all going to be drawn at the same x. So when I play this, they're all going to be drawn on top of each other. So what I want to do is spread them out a little bit. So maybe have one at 200, 400, 600, and 800. And now when I run it, I should get them across the screen like that. Perfect. Now, is there anybody who had any problems with that? Anybody who had any thoughts? Anybody who got some different behavior? Feel free to send it on the Discord. We're going to continue with the rest of it, which is, like I said, it gets into how to make this even more simpler, which are loops. So what are loops? Loops repeat code a certain number of times. So you see we have a similar pattern going on here. Last lecture was if statements. If statements run a piece of code sometimes, right? Only under certain conditions. This runs a piece of code multiple times. It repeats it. So for example, def draw is a big loop that repeats forever, right? This loop here, def draw, this repeats all this code infinitely, forever, right? So we can use that behavior to our advantage a little bit, and get some really neat things happening, save ourselves some time. And this is basically the format of it. You have the start of the loop, you have the code that you want to be repeated, end of the loop. Once it gets here, it jumps back up to the start of the loop and it runs it over again. And eventually it'll exit the loop and it'll run the code underneath after it runs this code a certain number of times, however many times you wanted it to run. Now, loops can repeat code in lists. So if we want to print out every item in this shopping list, we could print them all out manually, or we could write a list that prints out each item. So for item in shopping list, print item. We're going to look really closely at how this works. So let's go back to our example here. We actually don't need to be in draw because we're going to be creating our own lists. Sorry, just give me 1 second here. Okay, so this is our basic loop. Is we can have a list called numbers, or we'll make it like that. We'll make it like that list. So we'll go shopping items. Shopping items. And we'll do some things like, I can't remember what we had in there, but we have eggs. We have milk. Remember, these are strings, so we put them in between quotation marks. Milk, maybe we want some pasta, maybe some carrots. Okay, and let's say we want to print out each one. We could go print, and then we would go shopping items, and then we would print out the one at 0, and then we would copy this, paste it again, print out the one at 1, and copy it again, print the one out at 2, and keep copying it and keep pasting it and keep changing these. And if we had a really long list, like 100 items, we would have to do this 100 times. Or we can use this little trick, this loop, for item in shopping list. for item in shopping. R1 is called shopping items. And we have to put a little colon there. We can print out item. And if we do that, we should get each item printed out down here. So we still have our big window up here. Get rid of that. Eggs, milk, pasta, carrots. And it does it in order. So essentially what this does is there's a little bit of magic happening here. But basically what it does, I'll do this in a comment because I don't want to actually write code here. It takes a variable item and it sets it to shopping items at 0 for the first one. And then it prints out, then it prints out item, which it automatically set to the first element for us. Then the second time it goes through, it gets to the bottom, it comes back up to the top. Now it sets item to be equal to 1. Then it goes, repeats the next time, it sets item equal to 2. So kind of like how processing automatically updates mouse X and mouse Y with the current value of mouse X and mouse Y, this one automatically updates item with each of the items. So any code that you write here automatically gets executed for each of these items in the list. Okay, so you can't do anything with items, but if we change this to numbers, and I put in 1, 2, 3, 4, I could go print item. Let's say I wanted to do print item plus 10. Now for each item in here, for each item in numbers, we change the name, we're going to print out the number plus 10. So if we had it without this, we would get 1, 2, 3, 4. And if we did it with the plus 10, we should get 11, 12, 13, 14. Perfect. So any code you put in here is going to get executed on each of these numbers. And if we made the list longer, say 5, 6, 7, we would get all of those included too. So the program is smart enough to know how large your list is. And it'll do this. So for example, how many times will this run? It'll run 1, 2, 3, 4, 5, 7 times. Okay, and if we took away one of these, now it would run 6 times. Okay. Let's continue here. So we have a simple dartboard example. Now in this one, instead of storing their y positions or their x positions, we're going to be storing their diameter. This one's very cool. So if we have a bunch of circles and each of these diameters are decreasing by a certain amount each time, by 25 in this case, and we print all of the circles, we'll get this cool dartboard thing. Okay, feel free to try that on your own. I think it's pretty clear how this works. For diameter, diameter is a variable that gets assigned to each of these elements in turn as you go through. The first time it goes through this loop, diameter will have the value 200. The next time it'll have 175, and you'll do the same code. The next time it'll have 150, you'll do the same code, and it'll keep going through each of these values, and 25 will be the last one. Okay, we have another exercise here. a bar graph race. So you can either do this exercise, or you can try and do the last exercise, this one, except do it using loops. So either one of those two exercises you can do using loops, this one or the first exercise, and try and make 10 rectangles that grow bigger over time. Okay, now don't worry about them starting off screen here. You can kind of just have them all starting here. This is a little bit cut off here, but have them all start here and have them all grow at different rates. Don't worry about changing the colors for now. You can worry about that later. So again, if you need help at all, hop on the Discord, go into the general, and ask for help. You can also shout something out on the YouTube chat, and one of our mentors or myself will come help you. So go ahead, try this exercise, and if anybody has any cool things, if they figure it out early, they want to throw up a screenshot or throw some of their code that they got, feel free. All right. Has everybody had a decent amount of time to take a shot at this? If anybody is still working on it, or if anybody's finished, please let us know in Discord or on the YouTube. It's tough with these live lectures to get a handle on how long students are taking, if there's certain things students are getting stuck on. For now, I'll just assume that everybody's had a decent enough time to take their best shot at it, and I'm going to go over the solutions for both exercise 1 and exercise 2 using loops. So let's go over this first exercise we have here. So we'll hop into we have here processing and get started. So I'm going to make some space for global variables because I know I'm going to need some of those. So if we take a look back, if we take a look back at our bar graph, what we want here is, first of all, they're all growing at the same speed. So we don't need to keep track of 20 different speeds, even in a list. We can just have one speed, but they all have different starting heights. So they all started at different heights over here. So what we need to keep track of is, oh geez, how do you spell heights? I before E except after C. Does that look right? That's right. Heights, and then we're going to have a whole bunch of different heights. So let's just really quickly throw in, we'll do 10. So we're going to have different heights starting between 50, 20, and we'll just throw in a bunch of different ones here. It doesn't really matter what we do. 15, 27. That should be good. Now I'm not really sure how many we have here, but because we're using lists and we're using loops, it automatically keeps track of how many we have for us. So we don't actually need to know how many we have. We'll just write a loop that executes the code for each of them. Okay, so now in our setup, we want to do typical things. Set a window, and our background, we'll make it a little more pleasant. We'll make it a nice gray. Gray is when you have all three values the same. Okay, and our def draw. Now, what we want to do first off is draw a background. Same color we have above. We want to draw the background at the beginning of each frame. Next up, we're going to want to start drawing our rectangles. Okay, now to draw the first rectangle, what we would do is we would pick an x coordinate. Let's pick 0. We'll pick a y coordinate. We'll start it a little bit down the screen at maybe 100, and a width 100. So let's just see. Oh, sorry, I need a width and a height. So I believe this first number is width, and the second number is height. I guess we'll find out here. Right, so the 100 was width, and the 20 was height. So this looks pretty good. Now, back in our example up here, so we want the width to be increasing here. The height stays the same because the height is, the height of each, and the separation between them. So We're going to change this to widths. And then let's try and print out the width of this first rectangle in here. We're going to go rectangle the width. We're going to print out widths at 0. We skip over 0 elements to get to this 50. Okay, now let's print out this, and we should get a rectangle with that width. Perfect. Now, what would happen if we put this into a loop and we said for width in, this is a keyword that processing has. So we're going to say length. For length in, and why don't we change this one too, just for the sake. So lengths with an, length is also a keyword. We're going to say a length. How's that? So lengths with an S stores all the lengths, and a length is just one of them. It iterates through each of them. So for a length in our list lengths, we're going to draw a rectangle at 0, 100 with a length of whatever, with lengths at, I'm forgetting how to use loops. So a length, remember how we said a length gets assigned by lengths at x, where x goes through each of them 0, 1, 2, 3, 4, all the way up to the end. So a length just gives us each of these values in turn throughout the loop. Okay? Now, if we print this, we're not actually going to get all of the rectangles like we thought we were. In fact, this just printed 15 or 20 or however many rectangles we have here on top of each other in the same spot. So how do we get them separated out? Well, this is the x-coordinate. So the x-coordinate would be how far along they start here, which isn't what we're looking for to separate them. What we want to separate them for is going down like this. So we want to print each of them at a different y value. How far apart the y values are, we want them to be however high this part of it is, because they're all going to be separated. They're going to be right next to each other. So we somehow need to get 100 to increment by 20 each time we go through this loop. Okay, so why don't we start off by setting this to 0, so it starts in the corner, and you'll see why that makes sense. And we're going to have this other variable called start height. Okay, now start height is not going to be a list, it's just going to be a variable. And we're going to print this out at whatever the start height is. So for the first time we go through, the guy that has a length of 50, his starting height is going to be 0. Okay, but after we do that, we're going to increment start height by plus equals 20. So the second time we go through, this will have incremented once to 20. So now we're dealing with the second length, which is also happens to be, I'll call it 25 to avoid confusion. When we go through this 25 length, now we're starting a new rectangle, but instead of printing it at 0, 0, we added 20 to it last time, so we're printing it at 0, 20. And if we look at how that works, something went wrong here. Local variable start height reference. So does anybody see the problem here? We used a global variable start height without getting access to it. Okay, if you guys make that mistake, obviously I make it all the time. It's very irritating. Okay, so we're not getting quite the right thing happening here. So let's see what's wrong. So for each length in lengths, this starts as 0. We add 20 to the start length, and we print it at that. Start height plus equals 20. So if we get rid of this, we should have them all printing at 0. And then if we add 20 to it each time, height plus equals 20, I feel like this should work, but it's not quite doing what I want it to. Mentors, if anybody sees what I'm doing wrong here, feel free to shout it out. So each time we go through this loop, we want start height to increase by 20. Height plus equals, let's try 1. See what happens there. Oh my goodness. That's what's going wrong. Okay. So this is kind of an abstract mistake that I made. But when it goes through draw the first time, it prints out all the rectangles exactly like I want it to. And then when it goes through the second time, I want start height to reset back to 0. But it's not. It's after I go through the first time, start height, when it leaves this loop, it's like somewhere around 400. And then it goes again, and then it ends up at 800. So it printed them perfectly on the first frame, and then it prints them all down here. And then it goes like another, and then it prints them all down here. So what we need to do is reset start height to be 0 at the beginning of, I actually don't need to make this a global variable at all. Sorry about that. I was thinking of our last lectures. So we're going to have this starting height as 0. And it gets reset to 0 each time we go through and draw. And each of these rectangles gets printed at a start height. And then we increment start height by 20 for the next rectangle to print perfectly right beside it. That rectangle gets printed at that starting height. And we should get them printed all neatly like this. Perfect. All right. Sorry about that hiccup. So now the last thing that we need to do is we need to get them to grow. So how do we get them to grow? What does grow mean? Grow would mean that, like we said, growing is this length right here, right? Let's say I added 200 to all of these lengths. So whatever this length is plus 200, whatever this length is plus 200, and keep doing that for all of these. I get the same thing except they're all way longer, right? So somehow I need to figure out how to increase all of these lengths by an increasing amount each time. This is why I was getting confused, because this is what requires a global variable. Okay, so we're going to say grow speed. That's going to be our variable that determines how fast they grow. Now again, because they're all growing at the same speed, in this example, we don't need to have a separate grow speed for all of them, because if they're all growing at 5 pixels per frame, we don't need to have 5 for this, 5 for this, 5 for this, 5 for this. We don't need to have a 5 for each of them. We can just have a 5 for all of them. Okay, now because that one's a global variable, we do actually need to get access to it. Global grow speed. Make sure I spell it the same. Okay, and here, remember I put that 200 plus 200, and that made them grow just 200. Well, we want to make them increase by, sorry, no, this isn't speed. I want this to be just how much they've grown. Sorry, that might be a confusing mistake that I've made. So this is how much they've grown so far. So at the start, they haven't grown at all. Now, I want to increase their width by whatever their growth is. So the first time we go through this, every single rectangle that's being drawn has no growth. Okay? And in fact, if we print this right now, because growth is just constantly 0, they're not going to do anything here. But if we increase growth at the very end, outside of the loop, because we want this to happen inside the draw loop, each frame, not inside one frame, this would be inside one frame, but each frame, I want growth to increase by 5. Okay? Now if we play this, we'll see that all the bars grow. Okay, so really quickly breaking that down, we're drawing a rectangle at the length. This length represents each one of these elements, one after the other, each time it goes through this loop. Start height represents the height, the location of the corner that they're drawn from, right? I wanted each one to be drawn 20 pixels lower than the one above it, so that they all sit right next to each other. So start height is going to be 0 each time I want to start drawing them, and then after I draw it, I increment it by 20 for the next one. And I don't want this to be a global variable because I want it to reset back to 0 each time I enter draw, because each new frame, I want to draw them the same way, right? But growth changes frame to frame. At the start it's 0, now it's 20, 40, 50, 60, 100, 200, 600. So I want that to be a global variable because it changes frame to frame. So I add how much we've grown to each of their lengths, and then at the end of the frame, I want to increase their growth by 5 so that it draws them all with no growth. And then the next frame, it draws them with 5 pixels of growth, and then 10 pixels, and then 15, 20, all the way up to 600, and then they fly off the screen. Okay? So I'm going to introduce the challenge questions now. I know I promised to go over exercise 1, but I want to introduce the challenge questions because we went a little bit long on time with that one. So we have two pretty different examples here. This one on the left continues with our Pong game, except it makes it into a more complicated game. This is Brick Breaker. This game is pretty old, but the old games are really easy to code for us. So in this game, obviously you have your Pong engine, like we wrote in the review video or like we wrote in our last lecture. And the trick is that each time it hits one of these bricks, you want it to disappear and not count it as a brick anymore. You delete it. And the reason loops and lists are so helpful is because we have, it looks like 4 by 6 is 24 bricks here. So you don't want to write out 24 variables to keep track of each brick. You just want to write out one list called bricks that keeps track of each brick. Okay, and this example over here is maybe a little bit easier to wrap your mind around. We had that one example which is a screensaver, and it was just one ball bouncing around, but now you have a list of a bunch of different circles, and they're all bouncing around, and you're keeping track of all of their x and y values and all of their speeds. You can see that they're all moving at different speeds. Okay, so I'll leave this up. Feel free to talk on Discord or on a YouTube chat again if you need any help. And our mentors would be here to help you on Discord. So take a crack at it yourselves and see what you can come up with. Again, if anybody has any questions or you think you finished it, throw a screenshot up there. Maybe mention something cool that you found. Anything you want to share, feel free.